As for the introduction, what is the single most important killer feature of object-oriented programming and then functional programming?
You want to start? Because,
Okay, so I think that the best feature of object-oriented programming is the philosophy of objects and object-oriented ontology.
Okay. For me, the absolutely killer thing about functional programming is that if it works once, it works always. There's no exceptions, nothing. It's just like math. It just works.
Okay.
We like him!
Woo!
What if you turn the power off?
Come again?
What if you turn the power off?
Does
it still work?
What do you mean by turn the power off?
Does it still work?
Yes, of course.
Okay, let's move on to more serious questions. Let's start with tests, test-driven development. A question for object-oriented team. In pure functional programming, function result depends on its arguments. So it's quite easy to test. You pass a data structure, you have a result, and you assert this result against a value. In object-oriented programming, a test case typically involves quite a lot of setting up a state, right? So do you agree that it is easier to test pure functions than it is to test object methods?
Okay, so you said as an example that we need too much setting up the state in order to test objects, but I think it's a wrong assumption. I think it's a smelly situation if you have to set up everything in your test before you start testing it. So even in object-oriented programming, it's wrong. It's a bad code for me. So I think we are in similar situations when it comes to testing.
But still, you have to set some state, right? You have to initialize your object.
Yeah. And you have to initialize some data structures, right?
Fair enough.
Whoa, okay.
But the question there isn't that return value from a function is pure and always the same. And sometimes in testing object-oriented systems, you are changing the state that is encapsulated. I don't need a mic.
He's saying object-oriented programming sucks. Okay, so my point is that in functional languages you get always the same response for the same arguments. In object-oriented languages, sometimes you modify the encapsulated state, and then you need to write an assertion for that. And it forces you to do some isolation there, some assertions if something was called inside the object. Or you need to show the state, which should be encapsulated because it's object-oriented.
So I would say that in good OOP, there should be no surprise for you that something changes. And obviously, there are ways we deal with the state. We deal with the situation that state changes, and they don't. And I think it's perfectly fine if you are worried about the state changes. I think there is a bad design in your objects. So if you compare bad OOP to good FP, you will always win. So they will always win. But I think it's fine.
Okay.
Okay, so in functional programming, there are really just a couple of things, like you have data structures and you have your functions, and all you do is you apply those data structures into your functions. So in fact, testing is no different than writing a regular program. You just give, in tests, you give your functions different arguments. And that's all, basically.
Yeah, so just let me say one more thing before we continue with the discussion. And I would like to quote Martin Fowler. Sorry, guys. So here we go from his Blicky. Everything object-oriented programming can do can be done better in functional programming. The code is easier to write, runs faster, and uses less memory, and so on and so on. So you can look it up. But anyway, so...
So it's a call for authority, right?
Yeah.
It's not an argument, really.
I mean, it's Martin Fowler, come on.
They have to use
You cannot argue with Martin Fowler. But
Okay.
the last time I checked, like 10 years ago, I read something that Uncle Bob wrote about object-oriented programming, that a good program should be a program without side effects. And so if we have a method or something that has no side effects, how do we call that? It's a function, right? So the stuff that so actually I agree with Martin Fowler on that. So if you write proper OO code, you have the same as you get in FP. You just can't mess it up that much in FP.
Okay.
And by the way, if you think about it, everything is a function.
Yeah.
Okay, but sometimes it's all about the side effects, because if your code doesn't change anything in the outside world, then you don't have to run it at all. And when you have a real world application that you can use to buy some stuff,
to it. Okay.
Then you need to have side effects.
That's like saying you walk around and light buildings on fire and then say, we need fire extinguishers or this city's going to burn down.
Okay, a question for functional programming supporters. So in OO, you can use dependency inversion to test your object in isolation, to the degree you prefer. How can you test your function in isolation? I mean, how can you stop these lower level functions? Or do you test at all?
Well, first thing, it was already said that if it works, it works. And it really is like that. And the other thing is that in functional programming, you don't write like 300 lines of code, method or objects. You write very tiny functions. And
does it mean that you don't do test-driven development in functional programming?
No, it doesn't mean that. It means that you can take any function and put it anywhere, apply there any argument you want, and it will just work, and you can get the result. There is no magic needed. There is no some DI, whatever that is. I know, but I'm just kidding. All you have is just functions. It's math, pure math, no magic.
It doesn't answer the question.
Yeah. Can I comment on that? So what you do in functional programming and dependency injections is you have to pass in everything into a function. So by design, every function uses dependency injection in case you need it, something like that, right? And there is this other killer feature in functional programming called composition. And if you want to know more about composition, then buy this guy a beer and he can talk to you like for the whole night.
Okay, still, but when you want to test this function in isolation, in OO, you use polymorphism, right? And here, how can you choose whether you use your actual lower-level function or a stub? I mean, you can pass a stub to the function, but then how can you choose?
Give him the mic.
Just because you use a functional language doesn't mean you can stub things. If you
Why would you do that?
For example, in Clojure, you can use the binding construct to override global level things like functions.
Global what?
Like you define a function called foo, and the function called bar uses foo for something. You can stub foo if you need to, but another option is just to pass foo into the function. You can inverse dependencies just as easily in functional programming as in object-oriented programming, and the dependencies are more decoupled than in object-oriented programming, because in object-oriented programming you have a coupling on a function name, right? Even if you have duck typing, you still are coupled to the method name that you're calling. In functional programming, you don't. Well, if you program with functions, you don't have that. Every function, you're just coupled to the arguments that the function takes.
Thanks. Okay, modeling the world. So, as a Ruby programmers, I think we agree that high-level language is more productive than low-level one, and high-level means it is closer to the problem rather than being close to the metal. So how do you think? Is it easier for a human being to think in terms of cooperating objects, or rather in terms of functions processing data?
Okay, so first of all, I think that the perspective of the model of the world, is something that you believe in, that you can somehow model the world with following paradigms. So I think that guys that write functional code see all the world with the functions. Yeah, you have, I don't know. I think that our perspective from the object-oriented world is that we see everywhere objects that can have some behavior, some state, and the most interesting thing for me is how you, I don't know, how you perceive the reality.
What do you mean?
Who am I in your model? Who am I in your model?
If we look at this room here, we have a conference here, we have chairs, we have people. People sit on the chairs. And I don't think sitting happens to the people, and I think people sit on the chair. So I think I see objects here. They do some operations. They have some behavior, and they change state. So they drink beer. They have fun. How does it work in functional programming?
So I think the first problem is that it's a question of composition versus inheritance. And I think the world is a better place when it's modeled on composition than inheritance. Because essentially what it comes down to is, if you take object-oriented, essentially what you're saying is that there's a class called a car, and it has wheels and has other things. But then you enter the real world and you find out that all cars are different, and the amount of data and data structures in the world are a lot less than the amount of behaviors. So essentially it's better. Functional programming basically encourages you to build 100 functions that operate on one data structure versus object-oriented, where you have 10 data structures and 10 different methods that operate on them. And basically what it turns out is that if you're modeling something where there are more types than there are behaviors, OOP is the way to go. But if it turns out that there's a lot more behaviors than there are types, then functional programming is a better way. Because it completely separates out what is a data and what is a behavior. Actually, there's nothing that stops you in a functional programming language to build an object, because an object is nothing less than a function that returns a data structure with behavior attached to it. And besides, most of the time, in fact, that behavior never happens to a single object. So you have things like in Common Lisp, you have the object-oriented system in the Common Lisp, where the behavior is separated from the objects, because most of the time when you're operating on something, you're not sending a message to one thing from another. You're actually defining a behavior and an interaction.
Excuse me, I think you're arguing against class-oriented programming. Do you know the difference between class-oriented programming and object-oriented programming?
Yeah, so are you arguing that you're programming in JavaScript now? Because last time I checked, we were Rubyists.
Well, you can do OOP in Ruby.
Yeah, but that doesn't really change anything, though, does it? You still have a data structure.
You're arguing against inheritance, which is, even in the OOP world, is considered evil very often. So it's fine.
Why is inheritance evil?
Well, that's a different story, I think.
Because I think what a lot of...
In short, because it introduces tight coupling.
No, because I think what happens is that, I'm trying to say that polymorphism happens in many other ways than just inheritance, and even prototype objects. And when you're stuck with a OOP language, that's all you have left. You can only polymorphize, yeah.
Can I just go back to your question? What is this room or this conference look like in an FP world, right? So that's the question that you ask. So what I see here is basically, the first thing I see here is a collection. So basically the same thing that you have in OOP.
Say hello to collection.
Yeah, hi collection of people. So I have a collection of people.
We have a few questions, okay?
Wait. Just give me 30 seconds. So then you have a collection of data structures, right? So the properties that Andrzej was talking about, that's basically the same. I think the main difference is that behavior is not inherent into the data structure. You have a clean separation between behaviors and data. So it's a little bit like DCI. DCI is like a bad copy of functional programming in that kind of way, you could say.
Okay, so my question goes to the FP guys. If functional programming is so much faster, and I know it's available, you can run it in parallel, which is awesome. So how would you do testing in an environment that runs functions parallel in parallel? How would you ever test that? I don't know, one results before the other or so?
Yeah, I mean, concurrency is always hard, right? No matter what you do. So.
Wait. We don't want to get off the wrong foot. We have to define that there's such a thing as concurrency and parallelism, and they are not the same thing. Concurrency is a way to structure programs in such a way that there are things that are operating and they have no interactions. They interact with each other, but they do not cause side effects to each other. Parallelism just means that you can run many things together at the same time to improve performance. You often build a parallel system using concurrency, but they're not related. They're related, but they're not the same. Concurrency is a way to design programs such that there are many independent parts, and parallelism is a way of figuring out how different parts can run together in order to get better speed.
If I get your question right, then your question is how do you synchronize different threads or whatever in parallel, right?
We will move to it. We will move to it in a minute. So, and we will have a discussion in a second. So.
Just to talk about this question, right? Comparing functional programming, just give this point.
But shortly, please, okay?
So, first of all, I don't see here any object, I see here processes. So this is the first thing. Second thing, I don't see the big difference between object-oriented programming and functional programming because, for example, in my world, for example, when I have functional programming language which is process-oriented like Erlang, for example, I have state but keep it in processes. I have still functional code but state is keep it in processes, not in just objects, right? So this is very similar. In both worlds we have unit tests, and if in both worlds we have mocks, right? Yeah, we know about that. So let's don't talk about the border cases, but about real programming in normal world and normal application when you have state, because user making the request, user need to say something, user needs to make an, I don't know, system call, right? So let's concentrate on real example, not about talking about purity right now.
So I think you made a good point about Erlang, and I agree that Erlang is a good OOP language. So.
Okay, OO supporters, I have 4 cores in my mobile, and I would like apps to take full advantage of them. How can you imagine reasoning about highly multi-threaded programs in an object-oriented, highly mutating world? How can you reason about such program?
I never wrote such program, but I think that if you have few cores and few resources that can block your whole application, you write for each core, for each thread, you write separated objects that use some pools to get the objects that can be blocked, and it's quite easy. You can.
No, it's not.
Why? Because I mean, if you encapsulate the whole state in those thread objects, you don't have side effects on.
But it's still very easy to modify state of another object that you wasn't supposed to.
So you mean by reflection, something like this? It's
no,
like
why reflection? I mean, you pass object to another object, and these are used by different threads, and these different threads concurrently modify these objects, and it gets messy very quickly.
Okay, so in my world, you would use one object per thread, yeah? So you won't pass between threads.
The memory is shared between threads, right? By definition. So every object has access to another object.
If you would pass the access, yeah, by reference to in the thread. So if you won't pass, but create whole object structure on the thread level, and maybe pass some pool objects like, I don't know, database connection container, you don't have to, I don't know, deal with the concurrency in every object, but only in the common parts.
You do realize that creating whole objects is what OOP people laugh at about FP, is that we have to constantly keep copying the values. The only advantage is that we don't, because we can share the memory because it's immutable, and you can't, so you have to keep creating new objects. But I don't want to flame about that. I wanted to mention one thing about this concurrency thing. So concurrency means essentially that a system is non-deterministic. And parallelism means that essentially we're trying to create a deterministic system. And that's why the two things collide, and that's why it's so difficult to create. And the thing that functional programming gives you, pure functions that create pure values and don't have side effects, is the idea that I don't care that my system is non-deterministic, because in the end, sooner or later, I'm going to get the answer I want. That's why it's easier. That's the only reason why it's easier to reason about. It's that I accept the fact that it's non-deterministic, but it's not going to hurt me in any way.
So even if I assume for a while that FP is easier with concurrency, I think you pay a very big price for that, and the price is code that is difficult to read. When you look at object-oriented code,
we'll get to that.
When you read object-oriented code, you can actually imagine the structure, how it's composed, and what kind of behavior is happening. When I read, okay, maybe I'm not experienced in FP, but when I read FP code, it's just math to me, which is maybe good, but when I model real world, it's not math, it's just real world.
But I mean, is there a difference? Is there a difference for you if you have, different syntax and OOP? There are languages which are hard to read and others which are easier to read, right? So I don't think that argument holds up. So for instance, the syntax in Haskell, F# is totally different from Clojure, with all the brackets which you don't like probably. But it's totally different. And if you look at FP, which is maybe more closer to Python or something, though that...
But wait, because as this gentleman pointed out clearly, we're arguing about the wrong things. You're arguing about syntax right now. It has nothing to do with FP versus OOP. You're telling me that a system with OOP with side effects is easier to reason about than one where I see where it does, it's always going to do the exact same thing?
It's not about syntax, maybe it's lack of good examples. I really tried hard to find some FP examples and FP programs, and I find it very difficult to read. So maybe I was just not lucky with finding good examples, but to me it was just like a set of symbols put together, and it was difficult to understand.
I don't know, moderator. That's kind of weak.
Well, syntax is always a matter of taste and a matter of experience. And I guess if you take a person, okay, let's assume like everyone had a math in school, and then if you give him a object-oriented language with classes, interfaces, and all that something, and then you give him a functional code, and he can see like here's a function, here's some values. I suppose like the...
Here's some carrying, here's some fold L, here's some fold R.
Here's method missing, and here's hook, and here's AOP.
Yes, but they don't teach about folds in school.
It depends.
And filter and reduce and enumerable.
Yes, I can intuitively feel what I do when I do map, but folds are...
Right.
I mean, but the fold
beyond
is
my comprehension.
A fold is just an inject in Ruby. It's the same. It's just it has a different name, right?
True. This is true.
So we just need to change the names, and then everyone agrees.
Change the name to Ruby once, and they will be fine.
Okay, so let's just finish this by please explain monads, and that's fine.
Explain what?
Explain monads to us.
A monad is very easy to explain.
Or perhaps it's for the next discussion.
A monad is just a function. I mean, what's the problem?
Okay, thank you.
You're welcome.
Okay, it's the simplest definition I've ever heard. So thank you. Okay, and now functional programming supporters, you preach immutability, right? And rightly so. But in a real world, state changes anyway, and how can you deal with that, especially in a highly multi-threaded environment?
Well, one thing we should notice is that deep down in our computers, there's still a memory, there's still the hard drive, and there's still processors. and that stuff is stateful. Like memory is stateful, the hard disk is stateful, all databases, this shit is stateful. But the point of functional programming is to lift those things to make them unmutable. And by that I mean, like, if you write a function that, for example, fetches some records from database, it will get that database as argument. And in that way, your function is immutable. And of course using monads, but...
Yeah, I mean, so in the beginning, I think FP programming started with a simple assumption like in math. So a function is 1 + 1 always equals 2, right? Easy. And so for the first while, people tried to ignore the existence of state, but then they realized, actually, as you just mentioned, there is some state. So a program or a function is basically useless unless you print it to the screen or save it to the database or something. So there must be something like an adapter, something that crosses the two worlds, like monads.
Then this concurrency problems are back. So if you change the state, after all, how can you deal with that? Not everything can be immutable.
I mean, it's kind of hard. It's like you're not listening. Basically, the monad encapsulates the whole state change. It does it safely for you.
And is monad just a function?
Yeah, monad is a function.
Okay. So how do you deal with the state changes?
So now look, a monad is not different from any other function. You pass something in, you get something out, right? And it's predictable. I mean, there is a side effect which is encapsulated within the monad, right? So, but
so you just call it differently, and then it's fine, right?
Yeah, if you want, you can call it like there is a function which has some side effect on the outside world. That's monad.
Okay, but how about you mean that the function is always predictable, but underneath there's a database, and the database is not predictable because it can...
Wait, this is the exact same thing. If I asked you a loaded question, why does Ruby use a garbage collector which is non-deterministic? I don't know when the thing's going to start collecting. I don't know if it's going to run out of memory. I don't know lots of things. But you just kind of assume that it just works, right? And
okay,
no, you can't assume that, because sometimes you get just out of memory.
I have a fairly simple, I think, explanation of how functional languages deal with state. And the thing is that you separate your applications into two parts. Your core, which is functional, which is pure, and which is functions, which this part of your application tells how the world should change. And this is completely stateless. It gets some input and gives you some output. And then on your, and the shell of your application is dealing with state. Haskell has monads.
You just described a very well-designed object-oriented application.
Yeah, because actually object-oriented programming, good object-oriented programming and functional programming, I think, have a lot of things in common. But you don't have to use monads for state. Clojure has a very sane approach to state, and you have atoms, and you have refs and software transactional memory for this. And the main reason that it's sane is because it separates identity and state. So let's say you have a game, and the game state is stored in an atom called game, right? At any given point in time, this game has state, which is a value, which is an immutable object. If someone wants to print the game state to the screen, which is obviously a stateful operation because it's printing to the screen, they just have to obtain the value of game at this point in time, and they can go on printing it for hours, and it won't lock the rest of the application. It won't lock the other threads, because they can hold on to this value forever. It will never change, and other threads don't have to be locked.
But see, that was a good explanation. I think going off of what he said and what you said, I think an ideal programming language is something which does about 85–90% functional, pure, and then 10% with state changes. And essentially what you're saying is if good OOP programming is exactly that. but it's not. We don't do 80, 90% functional. I mean, most of us don't, at least, right? And the thing is, if your compiler knows that 90% of it is functional and doesn't have state changes in it, it can do things which it can't in a pure OOP language, because it just can't make those decisions for you. That's the nice thing about a little discipline in a functional programming language, is that essentially you're saying all of this all of this code, it's functional. It's non-deterministic. Do what you want with it. This is something you can't do in a pure OOP language.
Okay, we are heading to the end, and the final question is: do you find functional programming and object-oriented programming mutually exclusive or perhaps complementary? And perhaps we can start with OO team.
So
they still don't know what FP is, so.
Is it desirable to mix it or not?
I got a very simple...
Yes, certainly.
Okay, go on.
It certainly is very desirable to mix it, and our favorite language, Ruby, shows us that it's sometimes very, very nice to mix object-oriented and functional programming, and I wouldn't say they are exclusive, but the opposite, they are orthogonal. So one doesn't oppose the other. They can be combined and mixed, and that's what is best.
I think the modern functional programming languages, which are very popular, have they enable you to do both. Even Clojure, which has a strong Java background, gives you a lot of the things that are coming from object-oriented programming. And you can use parts of programs, libraries, which are written in OOP, whenever that is a better solution. And then for the rest, you use functional programming. Scala is another hybrid which out of the box allows you to write, like in one source code, functional and OOP. And F#, for instance, the same. So they mix both worlds very well.
The question and answers are iffy. Can I ask a different question? What is how do you think about OOP and accidental complexity versus essential complexity? Because I think that's an actual issue that we haven't discussed. Is how can you think about object-oriented programming and think, what does OOP give me to minimize accidental complexity and just focus on the essential complexity of solving problems?
I don't want to answer that question. I want to get into the previous one. And I forgot my answer. No, the previous one was that you use some object-oriented techniques in the functional programming or libraries, yeah? And we don't need functional programming in our object-oriented programs.
Just let me interrupt you. So if you don't need functional programming, why do you have things like map? Why do you have things like select, inject? Why does Ruby 2.0 have lazy collections? So if you don't need this stuff, so why is Ruby becoming more and more functional? Why do Ruby have lambdas?
Why do Ruby have blocks?
Is map functional? I think it's not.
Yes, absolutely it is.
It's dealing with the collection, and that's all.
It's a function on a collection. It's a lambda applied on every item in the collection.
You can't just monopolize some definitions and say that it's functional, and if we use it, we're doing functional.
Yes, I can, because Martin Fowler said that OOP. Because Martin Fowler said OOP is just a bad copy of FP.
So if I
no, he didn't.
He did.
No, he didn't. Can you read
He did. Come on.
The quote again?
Yeah, absolutely.
He said something entirely different.
He said, everything object-oriented programming can do can be done better in functional programming. Blah, blah, blah. Many features
it's something different.
Wait. Next paragraph. Many features and design patterns in object-oriented languages are imitations, poor by necessity, of those in functional programming. And that compiled object-oriented code cannot be optimized. No. End of quote.
No, but again, are we going to argue with syntax, Andrzej, or are you going to tell me something concrete? Essential complexity versus accidental complexity. OOP, how does it help?
Well, if I sit with a client and we try to solve problems, it's not really the first question that comes to my mind, how to limit accidental complexity and whatever else is.
But isn't that essentially what makes a project finish in a week versus a year?
I think it's a very important point, but it's not exactly the highest priority.
But can you tell me what is it about functional programming that most developers are able to do very simple programs before they run out of the brain power to comprehend what they are doing? So
this is good. This is good question.
Accidental complexity.
In functional
this is good question. If functional programming is so good, why isn't it widely used?
Well, first, one more thing. In functional programming, if you are inside a function with your cursor, you care only about this function and the arguments, and nothing more. In object-oriented programming, you have to deal about all of this global state, all of singletons, and other stuff that are all around, basically. And why is functional programming not that widely used?
It's a loaded question. Don't answer.
Because it is used. It is widely used.
Is it?
Not widely. Why not? You think so? It's not widely. Ask people about functional programming usage on a Ruby conference. I'm not that crazy. Okay, I will ask you. How many of you use map or filter? It is.
Okay, wait, one question. Everyone who uses functional programming, raise their hand. Now, everyone who has read Zed Shaw's Everything About Statistics, raise their hand. It explains a lot.
What is the problem that we can't adopt this approach as a programmers? Why is it so hard? Why do we love object-oriented programming?
Wait. Did you have math in school?
Yes.
Did you like it?
Yes.
Wait. Wait. Let me finish. How many of your classmates didn't like math? Okay. And what is your best guess? Why didn't they like it? And so, is it maybe because using your brain hurts sometimes? Is that possible? No. The reason is because most people are afraid to use their brain, and so they want simple instructions. But the question is more imperative versus functional or object-oriented programming. So if you want simple instructions like print A, then go to 1, that's the kind of thing that most people are doing, right?
So.
No, it has to do with
when you are preparing your food. Do you prefer a normal recipe or a haiku?
That's a very good example. Because if you have a recipe and it says use this and this and that, so this is a very good example of why object-oriented programming sucks. So you get a recipe which says you need 100 grams of flour, you need something blah blah blah. But the problem is the person that wrote the recipe had very different flour than you have. He had totally different ingredients. So if you follow exactly the instructions in the recipe and it makes boom, what comes out is a pile of shit.
You are taking this too long because I was just comparing the easiness of, I don't know, notation.
Yeah, because you don't want to, you don't like side effects, so you try to ignore them, but you can't because the object-oriented Ruby programming world is going to raise an exception in the moment where you don't expect it.
Okay, I have one question. We were talking about essential and additional complexity. Accidental, okay, accidental. What do you think about the complexity of creating many functions to handle things that could be written easily in object-oriented world? You say that the accidental complexity, it's only the result of the object-oriented failure, something like this. But if you want to understand what you're writing, I think that the accidental complexities in the functional language, because you really have to think, I don't know, 20 times, 100 times to figure out how function should behave. Yeah. So
okay,
what should it do?
So if everyone closes their eyes now, imagine that map and enumeral does not exist in Ruby, and now every single object that you write has to create their own iterator system, right? But map somehow, enumeral somehow was able to pull out this logic of iterating over a collection, and it applies to every single thing, and it doesn't matter what it is, and you don't care how it is built. Now,
Yes,
functional programming, wait, let me finish. So functional programming essentially says everything you do should be like enumerable. You should think about how you can build something so it's generic enough and global enough it can apply to any kind of data structure. And this is what I was talking about, essential complexity. Essentially, now there are words in most functional programming languages. If you buy me enough beer, I'll talk about how Haskell sucks and Clojure sucks and everything sucks. But the real thing is, when I'm sitting in front of a console and I'm writing Haskell, I'm thinking about my domain. I'm thinking about domain. How do I model my domain? When I sit down and do it in Ruby, I spend my first half hour just writing boilerplate code. And essentially, so at some point I'll figure out how to do this, at some point I'll figure out how to do this. Haskell's like, no, fuck you, man. You gotta figure out what you want first. And so that's essentially the difference between them. So imagine like a world where things like enumerable are scaled to times 100, and everything has to be generic.
We have 2 minutes left. Any closing thoughts?
I just like to get like 2 sentences about the popularity. I see 2 things. First thing is like no one likes math, and the second thing is 1 + 1 is not impressive, but print is impressive, kind of. Next thing is that at universities and schools there are most like C, Java and stuff like that. There are of course some Haskell and functional programming, and yes, functional programming is a little bit harder, but it pays off. And that's it.
So I think there is, between our camps, there is a lot of misunderstanding. So we argue against opinions that are not really opinions of the other camp. I like to admit that object-oriented programming has had a long way before, and we learned things. I'm in the camp that I believe that the typing uses classes, and in object-oriented programming is actually a very difficult way of programming. So I'm really glad that things like DCI are happening in the OOP world. And actually, I think that DCI is kind of a combination of OOP and FP. And this is where I would like to agree that we can combine those things and build good systems, I think.
Okay, so perhaps this is a very good conclusion that these paradigms are complementary, and there are more and more languages which allow us to combine those paradigms. And the one particularly I would like to recommend you is Scala. Scala combines those paradigms very well. It makes object-oriented programming much more immutable, and it's very expressive. It's almost as expressive as Ruby, and you can have functional programming at the same time. So have a look at that.
And
okay.
For Ruby programmers jumping into Scala, if you know what is int and string, it's easy. And trust me, really, go for it, learn it, use it then in Ruby.
Go for it.
Don't use Scala, use Clojure.
Okay, thank you very much.